Okay, now this lesson is being recorded. It picks up only our voices, so it does not pick up any video of us. It also picks up the board. So if you're absent, you can watch the video, or even if you kind of zoned out at some point in class and you want to watch the video. So just for those people who are absent today who may be watching this top equation just tells us how we find k. The bottom equation is the equation that we write. It's like what we did in Get More Math when we said that y equals something times x. K is that something. It's the unit rate. So if you're doing this at home, you might want to pause the video and take time to write this down. Okay, a couple of you are still writing. I'll give you a second. So we're on lesson 8. We already looked at this page. We're representing proportional relationships by equations. Let's take a look at example 1. Do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate, beginning a long road trip. And you notice that the low fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. A very practical problem here. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. Okay, so first let's take a look at mother's gas record. We talked a little bit about independent and dependent variables. Carly, which one would be the independent variable up there?
The miles, like the gallons.
The gallons would be. So the gallons, what letter do we usually use to represent that independent variable?
X.
X. So gallons is going to be our X. That's our independent variable. Because the number of miles driven depends on how many gallons are in the tank. So if there's not enough gas in the tank, we can't go. The miles driven depend on the gallons. So we're going to label that as Y. That's our dependent variable. Now, part A asks us to find the constant of proportionality and explain what it represents in this situation. Reed, what letter do we use to stand for the constant of proportionality? K. And how do we find K?
Y divided by X.
Okay, Y divided by X. So take a second and do Y divided by X. Let's see first if this is really a proportional relationship. So divide Y divided by X for each column in the table and see if you get the same thing. In real life, you probably wouldn't, but since this is a fabricated problem, it's probably going to work out. Does anybody have an answer yet? Grace? K equals 28. Very good. If we do 224 divided by 8, we get 28. If we do 280 divided by 10, we get 28. And if we do 112 divided by 4, we get 28. So it's a constant gas mileage. Not typical in real life. In real life, our gas mileage varies depending on whether we're doing highway driving or road driving. But for this problem, it's constant, so that's kind of nice. The next part says explain what it represents in this situation. We did this in the last lesson. David, can you tell me how you tell, where's David? Is he not here? Eli, I have your name wrong on here, Eli, from that first day. Eli, That's why I'm looking, I'm like, that's not David. Okay, Eli.
It means that for every gallon there are 28 miles driven.
Excellent. For every 1 gallon of gas, you can drive 28 miles. That's exactly how you could say that. For every 1 gallon of gas, you could drive 28 miles. Okay, our next question, part B, says write equations that will relate the miles driven to the number of gallons of gas. Adria, what equation would I write?
Y equals 28x.
Excellent. That's exactly right. Y equals 28x. And when we write an equation, we should also state what our variables represent. So Adria, what does Y stand for?
Miles driven.
Miles driven. So off here to the side, maybe I can write this underneath. Y stands for the miles driven. And what does X stand for?
Gallons of gas.
Gallons of gas. Now you don't have to use X and Y. We've been using X and Y a lot of the time. You could say, instead of miles driven being represented by Y, you could make that be M for miles. Sometimes it's helpful if you use the first letter. It helps you keep track of what you're doing. For gallons of gas, I'd probably use G for the word gallon and the word gas. But for this one, we'll go ahead and use X and Y, but for some of our other examples, we're going to use different variables. Okay, part C. Knowing, actually, let me take a look here. C, D, and E. Why don't I have you guys finish these in your groups, and then we'll come back and talk about them. In addition, no, let's hold off on example 2. So C, D, and E, you guys are going to take about 2 minutes and finish those up, and then we'll come back and talk about them. All right, part C, knowing that there is a ½ gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Pat, will she make it to the gas station?
No, because if you put 28 over 2,
Okay.
it equals only 14. But she needs to go 18, I think. 26.
Yeah, she needs to go 26,
Yeah.
so she definitely does not have enough. Okay, and you would want to explain. I'm not going to take time to write it out since you guys have all written your explanations, but make sure in your explanation you actually explain using words, not just showing, since it does say to explain. Any questions about part C? Okay, part D. Using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. Solve the problem in 2 ways, once using the constant of proportionality and once using an equation. Raise your hand if you solved it using an equation. Okay, Grace, tell me how you solved it using an equation.
I did y equals 28, 18, so 2800.
Okay, so we know that our equation is y equals 28x. So Grace is saying she knows what x is. X is 18, that's how many gallons. So y equals 28 times 18. And so then what did you get as an answer for y?
494 miles.
That's not quite it, I think you did. Did you do that by hand?
Yeah.
Devin?
504.
It's 504. So she could travel 504 miles. Raise your hand if you solved it without thinking about the equation. Pat?
Like, I don't know, I just added the 2, like how it already has the 8 gallons and 10 gallons. I just added the 2 miles, like, that it could be driven on this stuff.
Oh, okay. So going back to the table, I'll take care of this later. Going back to the table, he took the 8 gallons plus the 10 gallons makes 18 gallons, so he added these 2 numbers to find the miles driven. I like that. That's a different way of thinking about it. Anybody do it a different way? Okay, so when it tells you to do it twice, what it's looking for, really I don't care if you do it twice, but what it's looking for is you might have just thought, oh, well, you just multiply 28 times 18 without necessarily using the equation, but you would just multiply it that way. Okay, part E, a lot of people were a little bit stuck on this one. Using the constant of proportionality and then using the equation found in part B, determine how many gallons of gas would be needed to travel 750 miles. Irene?
So for this one, I took 750, and I used the calculator because I was
Okay,
not writing
that's
this
fine.
out by hand. And I divided it by 28 miles to the gallon, and
Okay.
I got 26.79. Well, it's like 78 balls.
Okay, what we're gonna do, since it was really long, is we're gonna use a curly little swirly equal sign, which means approximately.
Yeah.
And we're gonna go ahead and round that down. So let's round that to 26.8. Since it was 7, 9 something, the 7 would round up to 8. Okay, so Irene did this using arithmetic, basically. Arithmetic. Anyone do it using an equation? Anybody plug into the equation here?
We like got.
Okay, so you start, tell me how you started. What did you put in, our equation is y equals 28x. What do we know? What does the 750 go to?
It goes for the X. right?
Well, let's look back at the
Y.
table. Our x represented gallons,
Yeah.
y represented miles driven, and this is telling us how many miles were driven. So we want to substitute that in for y. So we have 750 equals 28x. What do we need to do then, Adria, to solve that equation?
750 divided by 28.
Yeah, we're doing exactly what the arithmetic people did now. So we divide both sides by 28, and we get the same answer. We get that x is approximately 26.8. Okay, if your homework asks you to do it both ways, you may just do it one way. I don't need you to do it both ways. You're doing the same thing, you're just expressing it differently. So either way is acceptable. Okay, any questions about example 1 before we look at example 2? Okay, example 2, Andrea's portraits. Andrea is a street artist in New Orleans. She draws caricatures, which are cartoon-like portraits of tourists. How many of you have ever had a caricature drawn of yourself?
I've seen them done.
Yeah, I think they're really, really neat. I've never had one done of myself, but it's interesting to see what features they pick out as being prominent in a person. So I like to look at them. All right, so people have their portrait drawn and then come back later to pick it up from her. The graph below shows the relationship between the number of portraits she draws and the amount of time in hours she needs to draw the portraits. Jimmy, which one is our independent variable on the graph? We have two variables. We have t, time spent drawing portraits, and n, number of portraits drawn. Which one is independent? The n, okay, so you think that the time spent drawing portraits depends on the number of portraits drawn. That actually makes sense, Jimmy. That's not the way it's shown in this graph, but you could actually make the graph the other way for this problem because that would work. You could say that the time depends on how many portraits drawn. But what we're doing here is we're starting with time, and we're going to say the number of portraits drawn depends on how much time she has to draw them. So on a graph, our independent variable is always on the x-axis, so this is always going to be independent. Kind of like how in a table, the independent variable is always on the left. There are lots of situations where the independent and dependent variable aren't obvious, and we could, in fact, flip them around. But when you have a table or graph given to you, you always assume that x-axis is independent, y-axis is dependent. Okay, part A says write several ordered pairs from the graph and explain what each ordered pair means in the context of this graph. So what this means, this question is a little tricky. You're going to pick an ordered pair represented by the line. So I'm going to look for a place where the line that's drawn, this line here that's drawn, actually crosses right in the center of the grid, because then it's easy to tell what the coordinates are. So I'm going to pick this point. All right, well, it's really hard to see up here. This point goes with the number 2 on the x-axis and with the number 3 on the y-axis. So my ordered pair is 2, 3. And what this means in the context of the graph, if I go down to 2, that tells me how much time was spent drawing a portrait. So in 2 hours, she will have drawn how many portraits? 3. She will, I'll just say she will draw 3 portraits. Okay, pick another ordered pair on the graph that works. Adria?
4 to 6.
Okay, 4, 6, that's a good point because that hits right in the center as well. On your paper, I have more lines on my graph than what
Yeah, you do.
you guys have there, I think. That's kind of interesting. Okay, so 4, 6. Adrian, what does that mean?
In 4 hours, she will draw 6 portraits.
In 4 hours, she will, ghostwriting. She will draw 6 portraits. Any other points that we can choose? I see another one on here that fits in the center. Dakota?
6, 9.
Okay, the point 6, 9. And Dakota, what does that point mean in the context of the situation?
She will draw, in 6 hours, she will draw 9 portraits.
Good. And the way you were going to say it before, you were going to start with she will draw 9 portraits in 6 hours, right? That's fine to say it that way, too. She will draw 9 portraits in 6 hours. And we could go on and on. You could pick points that were fractional, like, it would be kind of hard to tell, but you could say in 3 hours, she could draw 4.5 portraits. So you could pick other points, but it's easier if they line up exactly with the whole numbers. Okay, we're going to look at part C next. I'm not going to turn there yet. So we're going to skip B. We'll come back to B. We're going to look at C. C asks us to determine the constant of proportionality and explain what it means in this situation. Sky, what would the constant of proportionality be from the graph? Well, before you explain it, tell me what it is. What number would we say is the constant of proportionality? Well, we've done this from a graph yet. In other words, what's the unit rate? How many portraits can she draw in 1 hour? Eli? 1.5. She could do 1.5. If she can draw 3 in 2 hours, what did you do to get the 1.5? What did you do to these numbers here? Okay. 3 divided by 2 gives us 1.5. We could divide 6 divided by 4, 9 divided by 6. We can also look on the graph after 1 hour. We can kind of see this point. We could estimate that it's 1.5, but you really need to use the numbers you're sure of rather than estimating. It did work out to be 1.5 in this case. So the constant of proportionality, K, is 1.5, or we can write it as a decimal, 1.5. Okay, now back to you, Sky. Can you explain what this means in the context of our situation?
For every hour she draws a portrait, she gets 1.5 of portrait done.
Okay, for every 1 hour, she can draw 1.5 portraits. So she can finish one, start another. Okay, we just have one more question to answer. The bell is going to ring, so we're going to pause this. We'll resume. Okay, now we're going to go backwards to part B. Part B, the reason I wanted to start with C, part B asks us to write several equations that would relate the number of portraits drawn to the time spent drawing the portraits. We're going to start by writing the equation that we're familiar with using that constant of proportionality. Now, normally we've been using x and y. However, if we look back at our graph, it tells us what we're supposed to use. We're supposed to use t for the time spent drawing portraits and n for the number of portraits drawn. So over here, time spent is t, number of portraits drawn is n. Is our equation going to be an n equals or a t equals? Eli? It's going to be n equals. How do you know that it's n equals and not t equals?
Because it's on the y-axis.
Good. N's on the y-axis, so it's going to be an n equals. And then we're going to have k times t. And remind me, what was k?
Constant of proportionality.
Constant of proportionality, and specifically 1.5. So we have n equals 1.5 t. When it asks you to write several equations, what it's saying is when we find k, we're doing y divided by x. Well, when we found 1.5, I think most of you did it by using this point and doing 3 divided by 2. We could also do 6 divided by 4. Now, if we did 6 divided by 4 on the calculator, we're still going to get 1.5. But what it means over here is we could actually write n equals 3/2 t. We could write n equals 6/4 t. What's another equation we could write based on the points that we were given? Adria?
N equals 9/6.
Good. Really, I would prefer that this is the equation you write because I would want you to put your fractions in simplest forms, but that's what it's referring to when it's saying that you can write several equations. Okay, just to close, Taryn, what does K stand for? Not like what number specifically, but in an equation, what does the letter K mean? How many what? Okay, but in this situation, yep, how many she can draw in one, but in a more general. Jake, you want to help her out?
Constant of proportionality.
Good. K stands for the constant of proportionality. And what's another name for the constant of proportionality? Adria?
The unit rate.
The unit rate. We can also call that the unit rate. How do we find K? Kaylin?
It's whichever is
Okay, what you would divide x and y by, specifically what, in what direction are you dividing x and y? Other way. Y by x. We always do y divided by x to find k. And then what is the common equation we write to show that relationship, Michaela?
K equals whatever it is.
We had two equations. We had k equals, back a second, we had, where did I write that? Very first page. K equals y over x, but the equation we write would be the other equation. So we would want to write y, this one, y equals kx. Okay, your assignment is on the problem set. I would like you to do problems 1 through 5. Problem 6 is very tricky. If you want to do 6 as a challenge, I highly encourage you to do it. It's very thought-provoking, and I would really be interested in hearing how some of you have solved problem 6, because I would use algebra that I know to solve problem 6, but I don't think you guys know the algebra necessary to do it using algebra, so you would be doing it a different way. So I encourage you to do number 6, but you don't have to. The assignment is problem set 8, problems 1 through 3.
Wait, you just said 1 through 5.
I'm sorry, 1 through 5. Glad you're on your toes. Okay,